So we've seen how we can represent the survival function using the following expression. And the benefit of using this expression is we can directly estimate this quantity from data. So the probability that the time to event is at a given time can be estimated by looking at the number of patients who died at that time, so the number of patients who died at 25. In the denominator, we're going to look at the patients who have a time to event at or after 25. So this is going to be the number known to survive to 25. So we can estimate this quantity directly from data by looking at the number of patients who died at 25. And we see that no patients died exactly at time 25, so our numerator is 0. Now in the denominator, we're looking at the number of patients known to survive to 25. And patient 6 is known to survive to 25 because they have event times or censoring times after 25. And so the denominator here is 2. So we have here 1 minus 0, which is going to come out for 1 for this expression over here. And the reason for this is that we didn't have any patients who died at 25. And this is going to be true for most times in this expression. We're not going to have patients that died. In fact, the only 2 times for which we're going to see patients die before 25 are going to be for patient 1 at a time of 10 and for patient 4 at a time of 20. So this expression simplifies into computing this expression at those 2 times. So we have 1 minus the probability t equals 20 given t is at or after 20 times 1 minus the probability that t is equal to 10 given t is at or after 10. How we can simplify this expression to have these 2 terms. Let's see how we can simplify it even further. So we can evaluate this first quantity using the data by looking at the number of patients who died at 20 in the numerator. That's going to be 1. That's patient 4. And in the denominator, the number of patients that are known to have survived to 20. And so we can walk through the patients, see that patient 3 has survived up to 20, so has patient 4 and patient 6. So that's 3 patients. And we can have the 1 minus this quantity. And here we have 1 minus. We'll apply the same logic here, where in the numerator, we'll look at the number of events at time 10. There's 1. And we look at the number of events at or after time 10. So this is 1, 2, 3, 4, 5, 6. So we have 6 here. And now we can complete this computation where the first part evaluates to 2 over 3 and the second part to 5 over 6 to get us to 10 over 18. We can simplify that to 5 over 9, which comes around 0.56.